It's Sunday, April 3rd. The time is 1:23 a.m. New Zealand Daylight Time as we await the liftoff of our 25th Electron launch without mission abeat. My name is Alex Lanosia, a senior engineer for the Neutron program.
And I'm Felicity Powell, the education program lead here at Rocket Lab, and it's great to be with you for this launch. We're joining you here in the Rocket Lab Mission Control Center to take you through our 25th Electron launch today, a dedicated mission for Black Sky through Mission Manager's spaceflight. As we proceed with the countdown, Electron is now vertical and ready on the pad. Our first opportunity to launch comes at 01:41 local time or 12:41 UTC. If you're joining us from the United States, that launch time translates to 08:41 Eastern or 05:41 Pacific.
Our launch window today is around 2 hours. We have a couple of opportunities for instantaneous launches within that, but should we need to stand down from a launch attempt today, we have backup opportunities throughout this week and next to try again. However, with a smooth run through our launch operations so far, we're moving through our pre-launch procedures comfortably as we approach that T0 milestone. Today's mission is through launch services provider Spaceflight on behalf of Black Sky, a real-time geospatial intelligence company building a constellation of small satellites in low Earth orbit. Without mission abeat, we'll launch on a southeastern trajectory from Launch Complex 1 on the Mahia Peninsula, carrying two of Black Sky's Earth-observing satellites to a 430-kilometre circular orbit, where they'll join the rest of the satellites in the constellation. With this mission today, there will be a total of 3 deployments. You might recognise this sequence from our 2 previous back-to-back missions, Love at First Insight and A Data with Destiny, both of which used a modified kick stage to fit the 2 Black Sky satellites within Electron's fairing. The Black Sky satellite that sits on top of the top hat structure will deploy first, followed by the structure itself, and then the second Black Sky satellite will be released, signalling the end of the mission.
This process will only take a couple of minutes to complete and will begin at around the T+53 minute mark. We'll bring you a simulated payload deployment along with live comms from Mission Control to show you how it's done. Powered by artificial intelligence, Black Sky can use its constellation to monitor activities and locations around the world. This provides valuable insights to decision makers across government, commercial, and humanitarian aid industries. Here's more from Black Sky.
Today's launch will deploy the 5th and 6th satellites that we've carried to space for Black Sky in the past 5 months. These satellites will join Black Sky's current constellation of 13 smallsats, eventually expanding to over 60, which are used to provide on-demand, real-time Earth observation data and satellite imagery.
As we approach T minus 12 minutes, we're now coming up on the final go, no-go poll by our launch director to determine whether to proceed with the final minutes in the countdown. In this poll, each of our operators will check in from their stations to confirm their relevant Electron systems are operating as they should. Let's listen in to the roll call now.
All operators, this is the LD on mission, proceeding with the go, no-go sequence. Stage,
Stages go.
avionics,
Avionics, go.
GNC,
GNC is go.
VMS,
BMS is go.
T1,
T1 is go.
GC,
GC is go.
PLS,
PLS is go.
RSO,
RSO is go.
MET,
Mid is go.
and I have a go from MM, LD sub.
LD sub go.
That concludes the go, no-go sequence. We are T minus 24 seconds and counting. We are go for terminal count at T minus 10 minutes. From this time, the 3-word hold procedure is in effect.
And with that, Mission Control confirms that we'll be proceeding with the rest of today's countdown and moving forward to liftoff. We're at T minus 11 minutes and counting, and we are on track for liftoff at 1:41 a.m. local time.
GC, LD on mission.
LD GC.
Yes, sir. Please proceed with sequence 55, the pad terminal checks.
Sequence 55 in work.
Now, before we get into a little more detail about Electron, for those who might have missed our launch last month, we lifted off from Pad B here at Launch Complex 1 for the very first time. This is our third pad globally, allowing us to launch and then launch again without the hindrance of pad maintenance or recycle time. Pad B joins Pad A, which we're launching from today, at LC-1 in Mahia, the world's first private orbital launch site on the east coast of New Zealand. At Launch Complex 1, we're capable of supporting up to 120 launch opportunities every year. Now, unfortunately, we won't be launching Neutron from either of these pads. We'll be launching Neutron from Rocket Lab's Launch Complex 2 on Wallops Island in Virginia. Neutron is the program that Alex here works on, and it sounds like you're looking for colleagues.
That's right, and we're looking to expand the team fast. We've got roles in propulsion, vehicle design, analysis, and plenty more. So if you're interested in building the rocket of 2050 today, check out the careers page on our website at rocketlabusa.com. And if you haven't seen it yet, here's a sneak peek of what our new 250,000 square foot facility will look like. This building will facilitate rocket production, assembly, and integration, and will be home to our 5th Global Operations Centre for launch and on-orbit operations. Plus, we'll be launching and landing Neutron just down the road at the southern end of Wallops Island.
Stage 1 and Stage 2 high voltage batteries are ready for flight.
GC, LD on mission.
LD GC.
Please proceed with sequence 58, launch pad ready.
Sequence 58 in work.
LD stage mission.
Go ahead, stage.
All blips are nominal. Stage terminal checks are complete.
Roger, thank you, sir.
As we head into strongback retract, let's take a closer look at Electron on the pad.
Electron is our 18-metre tall, well, 18 and a bit today, two-stage launch vehicle made with carbon composite material, making it incredibly lightweight but also strong enough to withstand the forces of launch. While the carbon composite gives Electron its sleek black appearance, you'll notice here it now wears two white stripes. These stripes are made out of ice, formed on the outside of the rocket due to the very, very cold temperature of the liquid oxygen used to propel Electron into Earth's orbit. The liquid oxygen and kerosene propellant mix is used to power the 9 3D printed Rutherford engines on stage 1. These engines are named after Sir Ernest Rutherford, the famous physicist and New Zealander who discovered the radioactive element radon, as well as the concept of radioactive half-life.
That's right. Those 9 Rutherford engines power the first stage until Electron is at an altitude of around 70 kilometers above sea level. At this point, the next stage of the journey is carried by just one Rutherford engine, specially designed to work in the vacuum of space. We also have another engine named after another famous physicist, Marie Curie. Our Curie engine is the 11th engine on Electron and is housed within Electron's third stage, also known as the kick stage. This kick stage is important for delivering the payload to its exact destination in space. Today, after Electron lifts off the pad and successfully completes stage 1 and stage 2 burn to get us into space, Curie will then kick in to propel Black Sky's 2 satellites to a 430-kilometer circular orbit.
The kick stage is a small but mighty upper stage responsible for our incredibly accurate payload insertion, on average within just 1 kilometre of the target orbit. In order to achieve this high accuracy, we separate the kick stage just at the perigee of orbit as shown here. Today, satellites are headed to a circular orbit, but when we first separate the kick stage, it's on an elliptical first pass. It needs a propulsion system to boost it up into the right orbit for payload deployment, and that's where Curie comes in.
So we enter a coast phase for a period of time until the kick stage and attached payloads reach their desired apogee. That's when the Mark II Curie engine ignites for about 45 seconds to circularize the orbit ahead of payload deployment shortly after. From here, our Curie engine can reignite to lower the apogee, reducing the on-orbit time by up to 99.7%, doing our part to keep space nice and tidy.
Now, while we are best known for our rockets, we also make spacecraft components used on thousands of satellites all across the solar system. Rocket Lab manufactures reaction wheels and star trackers with our team at Sinclair Interplanetary, solar panels at Solero, separation systems from PSC, and in-space software by the Rocket Lab team at ASI in Colorado. We're fast becoming a one-stop shop for all things space.
That's right. If you've got a sensor or an experiment, we've got the components and the expertise to get your idea on orbit.
And so, at T-minus 4 minutes and 22 seconds, it's time to go to space. Electron remains in good health and the Black Sky satellites inside the fairing are good to go. The weather remains green and the path to orbit is looking clear from Launch Complex 1 at T0. Soon we'll hear the call that LOX loading is complete on Electron, telling us that the rocket is fully fueled for launch. Once the rocket has completed fueling, Electron's internal flight computers will take over the countdown to run the vehicle autonomously.
Our launch director will be counting down the clock from mission control from T-minus 10 seconds, and at T-minus 3 seconds, those 9 Rutherford engines we mentioned earlier will ignite before Electron lifts off the pad at T0. We're going to hand over now to mission control to check in with the operators ahead of launch.
That is ready for launch.
All stations, this is the LD on mission. From now on, there shall be no red flags on your critical LCCs. VMS LD on mission.
Go ahead.
Confirm flight computer as goes are green.
Confirm as goes are green.
VMS, lock auto sequence and confirm.
Auto sequence is locked.
All stations LD on mission. We are go for auto sequence start at T-minus 2 minutes. LD is go for launch. LD Shadow.
LD Shadow go.
Vehicle is on internal power.
Box load complete. Skate and recirc.
AFTS is green and enabled for flight.
Anti-geysering disabled.
Stage 1 and Stage 2 are pressed for flight.
High flow engine purge enabled. Water deluge is activated.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff.
Stage propulsion is nominal.
HV battery discharge is nominal.
And there we have it. Our 25th Electron launch vehicle is off the pad for this mission and progressing well on its way to low Earth orbit. Soon the vehicle will approach the point in its journey when it experiences the most amount of stress, maximum aerodynamic pressure, which is known as max Q.
And there we have it. We have word from Mission Control that we can confirm that Electron has successfully passed through max Q and is continuing on its southeastern trajectory off the coast of New Zealand. The first stage's Rutherford engines are firing perfectly as we come up to the next major milestone ahead of the first separation event for Electron.
AOS Chatham Station.
We're approaching main engine cutoff, or MECO. This is when Electron throttles down just a bit before shutting off those 9 Rutherford engines on stage 1 we mentioned earlier. This reduction in thrust allows for a clean separation of the first and second stages before the singular Rutherford engine on the second stage fires up and takes the satellites the rest of the way into orbit. We should see both of those actions on screen and hear the call-outs from our operators and Mission Control shortly.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition.
There we go. We have confirmed a successful transition from the first to second stages of Electron's flight, with MECO, stage separation and second stage ignition all nominal. You can now see the orange glow of the space-optimized
HV
Rutherford
battery
engine as it carries on into space.
protective shell at the top of Electron, known as the payload fairing, protects the satellites as the vehicle launches through Earth's atmosphere. Since we've now cleared the lower atmosphere, those satellites don't need that protection anymore. In fact, we need to jettison that protective shell so we can safely deploy the satellites to low Earth orbit.
Propulsion holding nominal.
There goes the payload fairing. Black Sky's satellites are now exposed to space, no longer needing this shell to protect them, as Electron has already punched through Earth's atmosphere to take them to their orbital destination. We've got a short time gap now between this latest event and the next one coming up for Electron's second stage, which involves swapping out the batteries that power the second stage Rutherford engine. The mission is continuing nominally as we approach that next milestone, with the second stage traveling at nearly 9,000 kilometers an hour at an altitude of 139 kilometers.
If you've just joined us, we've had a great start to today's mission so far. Electron successfully cleared the pad at Launch Complex 1 just a few moments ago, and we're now well on our way to space, having completed a successful pass through max Q, main engine cutoff, and stage separation to reach this point now in the mission. Electron's second stage, with the Black Sky satellites on board, is headed to low Earth orbit 430 kilometers above Earth, where they'll join the rest of Black Sky's constellation of Earth-observing smallsats.
As we continue without missing a beat, Electron is currently coasting in its second stage of flight before our kick stage kicks in and takes those two Black Sky global satellites to where they need to go. Mission Control is reporting all systems remain healthy on the vehicle as it travels at nearly 12,000 kilometers per hour.
Back to the mission on your screen, we're coming up to a milestone you'll see used only on Electron, the swap out of batteries that our Rutherford engines draw their energy from to continue operating their pumps. The vehicle has run through the set of batteries we started with at stage separation, and so now the second stage of the vehicle needs to swap over to a fresh battery to keep things going. We call this move the battery hot swap. We should hear that call come from Mission Control shortly, but keep an eye on your screen too, as sometimes you can catch a glimpse of them falling away.
Seconds remaining.
HV battery discharge nominal, approaching hot swap.
Starting throttle down.
Hot swap successful.
Battery jetting.
And there goes the call for a successful battery hot swap. You've seen the shiny silver object on your screen falling away from the second stage engine. Electron continues well onto its target 430 kilometers orbit, traveling at a speed of 16,000 kilometers per hour and an altitude of 200 kilometers.
HV battery discharge holding
Electron
nominal.
is currently in its second stage burn on the way to low Earth orbit to deliver Black Sky's payloads. We know that Black Sky's constellation can be used by all sorts of groups and
Stage
organizations
propulsion
between
holding
government, commercial, and aid. But what does that actually look like on the ground? To give you some idea, Black Sky's AI-powered constellation was recently used to evaluate the impact of the COVID-19 pandemic on shipping and supply chain logistics around the world.
Coming up next will be second engine cutoff, or SECO, on Electron's Stage 2. This manoeuvre follows relatively the same procedure as main engine cutoff, where the Rutherford engine on the second stage will throttle down before shutting off, ahead of separation between the second stage and the kick stage.
There will be a bit of a gap between kick stage separation and payload deployment, as this stage separation places the kick stage in an elliptical orbit of Earth first. We'll explain what happens then after we receive confirmation from Mission Control, first of SECO, and stage separation.
Entering burnout detect.
Guidance is in toner, 27 seconds remaining.
SECO.
And great news there from Mission Control with a successful SECO. The kick stage is now separated ahead of payload deployment, which is set to take place in the next 45 minutes or so. Due to the innovative payload design intended to keep Electron lean and efficient, we won't have live video of payload deployment for this mission. But we will be back to listen out for those final few calls from Mission Control, as well as watch an animated view of the end of the mission to visualize what's happening up there in low Earth orbit.
We'll take a bit of a break now, and we will see you back here in time for payload deployment in about 40 minutes or so. Stay tuned.
It's now T plus 52 minutes as we welcome you back to the live broadcast of Rocket Lab's 25th Electron launch. Felicity will take us through a bit of a mission recap and what has occurred so far.
Yeah, absolutely. Without mission a beat, this mission lifted off the pad at Rocket Lab Launch Complex 1 at 0141 New Zealand time or 1241 UTC. Electron had a clean pass through max Q, main engine cutoff, first and second stage separation, and then second engine cutoff and final stage separation of the kick stage. This kick stage is carrying today's pair of Black Sky satellites to low Earth orbit and is now coming up on payload deployment. Soon we'll see the last 3 events in this mission.
As we mentioned before the break, the Curie engine will ignite to position the kick stage in a circular orbit ahead of payload deployment. Then the first Black Sky satellite will separate from the kick stage at just the right spot at 430 kilometers altitude, next to the top hat extension structure that kept that first satellite attached to the kick stage while protecting the second satellite beneath it will be ejected. This then makes way for the deployment of the second and final satellite for this mission into its orbital plane. Those 3 events should happen within a couple minutes of each other, so let's cross over to this animated view of payload deployment to keep track of the process while listening in to mission control.
Upper payload deployed.
You heard it there. We now have confirmation that the first of the 2 Black Sky satellites have been successfully delivered to its new home in low Earth orbit. We'll give this satellite some space before we make the next maneuver, tipping our top hat, so to speak, to clear the path for the next satellite to deploy. That should be taking place shortly.
Payload adapter deployed.
That call out from Mission Control confirms we've had a successful separation of the upper stage extension. We're now on to the last event in payload deployment, separation of the second Gen 2 Black Sky satellite joining the other now 14 already on orbit. This should be taking place in just a few moments from now, so let's take a listen back into Mission Control.
Lower payload deployed. Mission success.
There it goes. Mission Control have confirmed the second Black Sky satellite has now successfully deployed to its new home in orbit. Welcome to space, Black Sky and spaceflight, and congratulations on a successful mission. Thank you for your continued support in this launch and over the last year.
And that completes today's 25th Electron launch, our second launch for 2022 and the first from our LC-1 Pad A this year, which now has a twin, just like those Black Sky satellites. Today's mission is another to start us off on what looks to be an exciting year ahead. For Rocket Lab, for our customers, and for the communities that use their satellites for everything from Earth observation and climate change research to weather monitoring, maritime surveillance, communications, and everything that keeps us more connected than ever.
With the acquisition of industry-leading technology companies Celero, PSC, Sinclair Interplanetary, and ASI, the Rocket Lab global family is now an end-to-end space company, delivering all of the resources and expertise needed to make space accessible to all. With Capstone, our joint mission with NASA to the Moon, launching soon, and the development of our new launch vehicle, Neutron, we continue to launch to new heights as we reach for the stars. If any of what you've seen or heard today excites you and you want to find out how you can join our team, visit rocketlabusa.com.
And that's it for our broadcast today. But you can always keep in touch with us and stay in our orbit by following us on social media to see, hear, and learn about what we do here at Rocket Lab. Thank you so much for joining us, and we'll see you back here next time. This is Rocket Lab Mission Control signing off.